Okay, so we've worked with these fractions. Now the next step is to look at combined operations with fractions and mixed numbers. So just like we did with whole numbers, we can have something like this. 2 1/2 plus 1 2/3 times 3/4 plus 3/8 times 2/3 minus 1/2 plus 3 1/4. Now, this is exactly like our other order of operations problems. It's just seeing the fractions in there tends to make us panic just a touch. But it's all still the same. We're going to start inside the parentheses here. And our order of operations still applies in there. Are there any exponents? No. So we move to multiplication and division. So we've got 3/8 times 2/3. Now I'm going to write that off to the side and do it out. 3/8 times 2/3. The 2 and the 8 cross cancel will give me 1 and 4. The 1 and 3 cross cancel is going to be 1 and 1. So 1 times 1 is 1, 4 times 1 is 4. So my 3/8 times 2/3 is just 1/4. So the rest of the problem stays the same. Now we're still working inside this parentheses. There's no more multiplication or division, so we're going to add or subtract going left to right. So we've got 3/4 plus 1/4, which is 4/4, or just 1. Next, we're still inside the parentheses there. We have 1 minus 1/2, which is 1/2. Again, if we were doing that out the long way, we would have to make this 1 over 1. Common denominator is going to be 2, so that stays 1/2. 1 times 2 makes 2, 1 times 2 makes 2, so 2 over 2 minus 1 over 2 is 1 over 2. Now, I have a single number inside the parentheses, so I can get rid of the parentheses, but I do have to remember to put multiplication in up there. What's my next step? 1 2/3 times 1/2. So I'm going to write that off to the side here. 1 2/3 times 1/2. 1 times 3 is 3, plus 2 is 5/3. Times 1/2. 5 times 1 is 5. 3 times 2 is 6. That's 5/6. Now what? We're going to add left to right. So 2 1/2 plus 5/6. Well, this is going to be 2 3/6 plus 5/6. 6 is our common denominator. We are going to add to get 8/6, which is 4/3, or 1 1/3. So I keep the 1/3 and carry the 1. 1 and 2 makes 3. So this is 3 1/3 plus 3 1/4. So that is going to be 3 4/12 plus 3 3/12, which is 7/12 and 6. So 6 7/12. So it's really no different than doing order of operations with whole numbers. Really the big difference is every step we're combining fractions instead of whole numbers. So with whole numbers, we're used to being able to just look at it and know what the result is. since these are fractions, we have to write them out to get the results. So here it was just, 6 or 7 operations with fractions is all it really was. And of course, you do have the fraction calculator. It is okay to look at this and say, okay, I have to add 2.5 plus 5/6. It's okay to punch that in the calculator and see what it spits out. A little bit different from that, we might run into ones like this. 3/4 plus 1.5 times 2/3 over 3/4 times 1/6 plus 1.5. This is really 2 separate problems. I'm going to do everything on top first. So 3/4 plus 1.5 times 2/3. What do I have to do first there? 1.5 times 2/3. Now if you multiply that out, you're going to get 1. And I'm going to let you guys... Yeah, because 1.5 is going to be 3/2 times 2/3. 2's cancel out, 3's cancel out to be 1, so it's 1 over 1 or 1. So 3/4 plus 1 is just 1 3/4. So the top of that becomes 1 3/4. On the bottom, we start out with 3/4 times 1/6, which ends up being 1/8. 3's cancel, 3 and 6 divided by 3 to give me 1 and 2. 1 times 1 is 1, 4 times 2 is 8. 1/8 plus 1.5. So I have 1/8 plus 1.5. The 1/8 is going to stay. 1.5 is going to become 1 4/8. So 1/8 and 4/8 is 5/8, and we have 1, so 1 5/8. So we've done the 2 separate problems. We still have to combine them by dividing 1 3/4 by 1 5/8. So our first step, of course, is to go improper. 1 3/4 will be 7/4. 1 5/8 will be 13/8. We change it to multiplication, so 13/8 will become 8/13. 4 and 8 both divide by 4. Give me 1 and 2. 7 times 2 is 14. 1 times 13 is 13. So it's 1 and 1/13. What do you think? Are we still looking at better than a sharp stick in the eye? Okay. Now we can throw variables into those complex fractions. We can have something like, let's see, 24 over y squared over 8 over y to the 5th. All this fraction bar means is divide. Of course, it means if there's anything to do on top, you have to do that first. And if there's anything to do on bottom, you do that next. Then you divide. But here, there's nothing to do on top or bottom. So this is just going to be 24y squared, or 24 over y squared, divided by 8 over y to the 5th. So that's 24 over y squared times y to the 5th over 8. Very good. So now we could cross cancel or we could multiply it out and reduce. It really doesn't matter. If I multiply it out, 24 times y to the 5th is 24y to the 5th. Y squared times 8 is 8y squared. Well, 24 divided by 8 is just 3. And the y goes on top because the larger power is on top. 5 minus 2 is 3. So it's 3y to the third is all it is. Get back here. So we can run into fractions within our equations. 2/3 x equals 4 and 4/5. To solve something like this, it's going to solve exactly like 5x equals 65. How would we solve this equation over here? Yeah, you divide by 5. We're going to do the same thing over here. We're going to divide by what? 2/3. Now notice I used the divide sign instead of that just because it's simple, but I could have just done that. So the 2/3 cancels out. It's just that over here I have, just like with the order of operation stuff, I have an operation with fractions to do. So it's 4 and 4/5 divided by 2/3. 4 and 4/5 becomes 24 over 5. Since I don't have to change this into a mixed number, I'm going to go ahead and invert it right now. So we times 3 over 2. I can cross cancel the 24 and 2. Give me 1 and 12. 12 times 3 is 36. 5 times 1 is 5. So that's 7 and 1/5. X equals 7 and 1/5. As always, we could double check it. We could punch in our calculators, is 2/3 times 7 and 1/5? Does that come out to be 4 and 4/5? And if you punch it in, it will. So what do we have to do here? Exactly, we're going to subtract the 2/5. So that's gone, leave us x there. We subtract 2/5 from the other side. So we have 5 and 9/10 minus 2/5. What do we have to do? Well, we find a common denominator, which will be 10. So this is 9/10, and this is 4/10. 9/10 minus 4/10 is 5/10, otherwise known as 1/2. And the 5 minus nothing is still 5, so it's 5.5. So x equals 5.5. Not so bad? Y minus 2 and 3/4 equals 5 and 2/3. What do we have to do there?
Add the 2 and 3/4.
Perfect. We add 2 and 3/4. So that's gone. We have y equals, what is 5 and 2/3 plus 2 and 3/4?
Find a common denominator.
You are correct. We do have to find a common denominator. And it is going to be 12. This is going to be 8, and this will be 9. 8 and 9 makes 17 twelfths, otherwise known as 1 and 5 twelfths. Good. We keep the 5 twelfths. Carry the 1. I don't know why I came up with 6 there. That should have been 8. So y is 8 and 5 twelfths. Any questions? Okay. I'm going to have you try this one in your notes. It just combines a couple of steps. I want to see how you can do with it. What do we do first?
Add the 1.5.
We add the 1.5. So that's gone. We've got 2/3 x here. 3 and 5/6 plus 1.5 is 5 and 1/3, correct?
Yes.
Perfect. What's next?
Subtract the 2/3.
Careful.
Oh,
The 2/3 multiplies the x, so we have to divide by 2/3. Perfect. So we've got 5 and 1/3 divided by 2/3. 5 and 1/3 is 16/3 times, I'm going to make that 3/2. 3's cross cancel, giving me 1 and 1. Divide out a 2 to give me 1 and 8. So I've got 8/1. So x equals 8. So really the biggest difficulty is getting past the view of the fractions. For some reason, when you see the fractions in there, for a lot of students, it tends to send their mind in kind of a spin, and they don't see it as just the whole number. And that, I'm glad you actually made that mistake. That's a very common one here of saying 2/3 and saying I gotta subtract the 2/3, because they don't see it connected the same way they do if there's whole numbers there. But it is multiplied, so we have to divide to get rid of it. Now, a fraction form that comes up might look like this. X over 7 equals 5. And there are two ways we can think about this one. In a simple equation like this, probably the easiest way to think of it is that's x divided by 7. So to solve it, we just multiply by 7. That cancels out the dividing by 7. 5 times 7 is 35, so x equals 35. Which, if you went back to double check it, put 35 in for x. 35 divided by 7 is 5, so that does check out. Well, the other way we could look at that original equation is that x over 7 is really 1/7 x. Right? Because if you think about it, 1/7 times x will be times x over 1. 1 times x is x. 7 times 1 is 7. So it really is 1/7 x. So then I would solve it by dividing by 1/7. Well, 5 divided by 1/7 is still 35. So in this case, it's probably simpler to look at it as this, as being divided by 7. However, we will run into problems like this. X over 7 plus x over 3 equals 20. Well, here we can't think about it as being divided by, because x would be divided by 7 and it would be divided by 3. That wouldn't make a whole lot of sense. So it's easier to think of it as 1/7 x plus 1/3 x equals 20. Now, some of you might be looking at that right now thinking that doesn't look any simpler to me, but it really is. If you think back, we had problems like 2x plus 5x equals 35. What did we do with this? Yeah, we combined 2x and 5x to make 7x. So now the x only appeared once. We combined them to make 1x. Or one single appearance of the x, I should say. We're going to do the same thing here. 1/7 x plus 1/3 x. Here it was just 2 plus 5 makes 7. Here we got to do 1/7 plus 1/3, which is 10/21. I'll let you guys do out the math to confirm that, but that's what it comes out to be. So this is 10/21x equals 20. Any questions so far on what I did? All I did was add 1/7 to 1/3 to get the 10/21 x. Now what? X has been multiplied by 10/21, so yes, we divide. So that's gone. We've got x equals 20 divided by 10/21. That's going to become 20 over 1 times 21 over 10. 20 and 10 cross cancel, give me 2 and 1. So it's 42 over 1 or just 42. X equals 42. Fractions can sneak into our equations like this. Three x plus 7 over 4 equals 7. What would we have to do to solve that? Well, here we've got to look back at what's been done to our variable again. If x were a number, the first thing that was done to it is it was multiplied by 3, right? Then what? Added the 7. We have to do everything on top first, right? Then the whole works was divided by 4. So to take that apart, we have to reverse that process. We have to get rid of the dividing by 4, which means we're going to multiply by 4. So what that does is it removes the 4 over here, and we're left with just 3x plus 7. Over here we have to do 7 times 4 is 28. And then the rest looks pretty familiar. What do we do next? Subtract the 7. That removes the 7, leaving us with just 3x. 28 minus 7 is 21. And then we divide by 3. Removes the 3, leaving us with x. 21 divided by 3 is 7. So x equals 7. So we might run into, come on, 5x minus 2 over 7 is 4. I'm going to let you try that one in your notes. See how it goes. I guess I can't get up to that whole problem, so let's put it up. What do we do first here? We're gonna multiply by 7. Very good. What's that give us? 5x minus 2 equals 28. Okay, and then what? Add the 2. Okay, and then?
5x equals 30.
Okay, and then next?
Divide by 5.
Divide by 5.
X equals 6.
X equals 6. Good. Any questions on that one?
I'm just writing that down.
Well, hopefully the shock will wear off after you get a few of them right? Well, let's throw you into the fire here. This one's exactly the same, only there's fractions. Okay, so what's our first step?
Multiply by 7/8.
Perfect. We're going to multiply by 7/8 on both sides. So on the left, what do we have? 2/3 x minus 1/4. On the right side, we have to do the 4/5 times 7/8. Comes out to be 7/10. Any questions so far? Okay, what's next?
Add the quarter.
We add the 1/4. So we got 2/3 x equals
19/20.
beautiful, 19/20. Then what?
Divide 2/3 or multiply 3/7.
Perfect. We divide by 2/3 or multiply by 3/2, which gives us
57/40.
57/40 or 1 17/40, right? So it's not so bad, right? I'm not hearing any answer. I'm not sure if that's good or bad. It does take up almost a full sheet of paper to do one problem because you have to do all the fractions. And like I said, I do totally understand if you guys need to use the calculator to do the operations. Okay, well the good news is that is it for new material.